Hi, everyone. Welcome to the Stellar Development Foundation's Engineering Talk series. My name is Leigh McCulloch, and I'm a software engineer at the Foundation. I'm one of the people working on improving the experience that individuals have using Stellar and that businesses have building on Stellar. And today I'm talking about Stellar Ecosystem Proposal 30. SEP-30 is an approach to make Stellar key management user-friendly in products built on Stellar. So user-friendly key management is maybe a bold statement to make because key management is rarely user-friendly, but that's what we're going to talk about today. First, I'm going to set some context and touch on what key management looks like on the Stellar network, how key management relates to wallets, and then some common approaches that wallets take in the Stellar ecosystem and in the blockchain space in general. Then we'll jump into the approach taken by SEP-30. We'll walk through an example step by step of how SEP-30 works, and then reflect on why this is valuable. We'll also have a Q&A at the end. So if you have any questions during the talk, please drop them into the YouTube chat box and we'll get to them at the end. So what is key management and why do we care? At the core of owning a Stellar account or an account on many blockchains is being in possession of a key. On the Stellar network, if you have an account, you have a key for that account. A key is made up of two parts, a public key that you share with others and a secret key that you keep private. This is an example of what the public key looks like, what a public key looks like on the Stellar network. It starts with a G. The public key is your account address. People send funds to this address and they'll show up in your account balance. And this is what a secret key looks like. It starts with an S. On the Stellar network, we call the secret key that defines your account address the account's master key. If you create a new account on the network and don't change its configuration, your master key is what you use to sign transactions. It's what you use to control your account. So what do we mean by signed transactions? Stellar accounts have signers. A signer is a key that can authorize transactions for a Stellar account. And the master key, it's the default signer of the account. Being a signer of a Stellar account is sort of like being a signer on a bank account. You can sign checks for that bank account and banks will accept the check as valid. If you get a new account on the network, it's got one signer, and that signer is the master key. But accounts can also have more signers in addition to or instead of the master key. A signer is a signing key, just like a master key. Accounts can be configured to let signers authorize transactions individually or together in a group. On Stellar, that configuration for what combinations of signers are required to authorize transactions is controlled by setting a threshold on the account and then weights for each signer. An example of this could be an account that has a threshold of 20 with signers that each have weights of 10 need two of these signers to sign a transaction for the transaction to be valid. Another example might be an account that has a threshold of 1 where any signer could sign the check by itself for the check to be valid, much like a basic joint bank account. You'll hear people use the term multi-sig to refer to accounts that use multiple signers, but most accounts on the network only use the master key, and so they only have one signer. Some wallets have used an additional signer as two-factor auth, but control of the account still hinges on possession of that master key. So key management is how we manage all of these keys, and wallets play a pivotal role in key management because at the core of a wallet is key management. A wallet's core job is to hold your Stellar account. And so its core job is to store your key, protect your key, help you use your key to sign transactions, and then prevent you from losing your key. So let's talk about some common approaches to key management that are being used. So many wallets, they only use that master key. This means your account has one key, one signer, and that key is stored on the device in the wallet application. Those wallets then help you to not lose your key using a few different methods. One approach is to give you the key in some form to write down or to print out. The key lives in two places. It's in your wallet on your phone, and it's on paper as a backup if you lose your phone. This is great in terms of simplicity, really straightforward to implement. Your key is backed up, but it does present some challenges. It puts a lot of responsibility on the user. The user needs to write down that key exactly correct. If they lose the paper it's written on, they've lost their backup. If someone else finds the paper, their account is easily stolen. And it can be a jarring experience to ask a new user to write down a lot of text immediately after they've installed a new application that they may not be committed to. Another approach is to store a copy of the key on the wallet server, but this has some different challenges. The user's got to trust the wallet server completely because the server will have access to the key and therefore control of their account. Some wallets address this challenge by encrypting the key using a password that the user enters into the wallet but is never shared with the server. This means the wallet server is not able to use the key because it cannot decrypt it. But this only works for wallets and products that require the user to make a password that won't be shared with the server, which is yet another password for the user to lose. So all wallets do key management, but most focus on managing one key, that master key, and backing up that master key. So let's talk about the approach that SEP-30 takes. SEP-30 Recoverysigner is a stellar ecosystem proposal. That means it's a proposal that contains a new standard or a change to existing standards that is built on top of the Stellar network and for use in the Stellar ecosystem. SEP-30 is an approach to key management that's focus is making key management and specifically the preventing loss part as user-friendly as any other consumer application. Its goal is to work without recovery phrases, to have no server with sole control of the account, and to not require the user to remember a secure encryption password to encrypt their key. SEP-30 is currently being used in one wallet, the Vibrant wallet, which is a non-custodial US dollar saving wallet that stores value on the Stellar network. The Vibrant wallet is currently in open beta and presents a user experience designed for the general public. You log in with your phone number, you don't need a password. A wallet like Vibrant that is implementing SEP-30 still does many of the same things that other wallets do. They store a key, they protect a key, and they help you to use your key to sign transactions. And they prevent loss, but the loss it prevents is different. It prevents you from losing your account and not your key. A wallet implementing SEP-30 won't manage and back up a single master key. Instead, the wallet will manage device keys and help the user to get new keys. The user's Stellar account won't change. Its address will stay the same, but the user's signing keys will change. So let's have a look at what SEP-30 is. SEP-30 defines an API that provides two endpoints, one to register accounts and another to sign transactions for that account. A wallet uses that first endpoint to register an account with the server. In the request, the wallet tells the server what identities are allowed to request signatures for the account. Those identities can be things like a phone number or an email address. The wallet authenticates using SEP-10, which is a Stellar ecosystem proposal that's widely used already that defines a challenge response authentication flow that the wallet uses to prove to the server that it possesses keys that can sign for the Stellar account. This way that the server knows that the client should be allowed to define who can sign transactions for that wallet. In the response, the wallet gets back a signing address for the server, and it makes that address a signer of the Stellar account. The second endpoint is transaction signing, A wallet calls this endpoint with a transaction it wants the server to sign. It'll do this when it has lost its key and it needs the server to sign transactions for it. The wallet authenticates using an identity provided during registration. If the phone or email matches an identity stored with the account on the server will sign the transaction for the Stellar account and return that signature to the wallet. So let's have a look at an example and we'll walk through how a wallet can use these two endpoints to support account recovery. For the example, we'll give the user who is using the wallet a name and we'll call her Alice. When Alice creates an account with the wallet, the app on her phone is going to generate a master key, and then the wallet server is going to create the account associated with that master key. The master key will be one of those big S secret keys that we looked at the beginning, and it's the red key in this diagram. The red key never leaves Alice's device. The app on her device doesn't give this key to anyone. With SEP-30, we can implement this wallet so that there is no need for the master key to be backed up anywhere. Alice's wallet also generates a second key, what we'll call her device key. It's a key that is only for this device to use to sign transactions. In the same way that the master key is not shared with anyone, the device key is not shared with anyone either. Alice's wallet submits a transaction to the network, making that device key a signer of the account and removing the master key as a signer. Alice's wallet then deletes the master key. It's not useful anymore. The wallet then goes through the process of registering the account with two recovery servers. Each server has their own key that they generate themselves. Each server is hosted and controlled independently by different entities. The wallet proves to each server independently that it has authority over the account by signing a SEP-10 transaction and tells the two recovery servers that anyone who can prove possession of the user's phone number or email should be allowed to request transactions to be signed. The wallet submits a transaction to the network, adding both recovery signers as signers on the account, but limiting the weight of their signatures so that neither recovery server has independent control over the value in the account. Each recovery server will be able to sign a transaction at the request of the user, but the transaction will only be authorized if signed by another independent party. The only individual with independent control of the account is Alice. Here's an example of what it looks like on a public block explorer on the public Stellar network. This is an account on the public network with its threshold set to 20, and there are 4 signers. The master key at the bottom with a weight of 0, meaning that it has no control over the account. A device key with a weight of 20, so that the device has complete control of the account. And then 2 recovery servers that each have those weights of 10. So let's imagine that Alice has lost her phone and she's purchased a new phone. The grayed out phone in the top left is her lost phone that still has her device key on it, and her new phone has no key for the account. Alice's new phone goes through the same process that her previous phone did when it signed up with the wallet server. It generates a device key and it signs into the wallet. But that new device key is not a signer of her Stellar account, so her device cannot authorize transactions yet. The wallet app talks to the first recovery server and asks the server to sign a transaction that makes her new device key a signer on the account. Alice then continues recovery with the third-party recovery server. The third party is operating independently, so Alice authenticates with them independently with an SMS code sent to her phone number or a link or a code sent to her email address. Once Alice has authenticated, the server signs the transaction and returns the signature to the wallet. The transaction has now been authorized with a weight of 20 and can be submitted to the network. The transaction removes the old signing key that was lost with Alice's previous phone and adds the new signer key that lives on Alice's new phone. Alice is now back in control of her account. Finally, what's important to highlight is that while Alice is in full control of her account, this process can be built into the wallet application, and be behind the scenes for her. What Alice experiences is the same user experience that we've grown accustomed to in consumer applications, which leads us to why SEP-30 is valuable right now. Great user experience drives adoption, and supporting account recovery through phone and email brings a non-custodial wallet's user experience closer to that of other consumer applications. The registration user experience for Alice can be that she signs up like many consumer products, logging in with her phone or her email. And the recovery user experience for Alice is similar, requiring only a second SMS or email with a third-party recovery provider. These are patterns that are familiar to users of consumer applications. This approach is also very flexible, allowing a wallet to still offer a recovery phrase that can be written down by generating an additional key to be that recovery phrase, or to allow for multiple devices, where each device generates its own key that never leaves that device. This approach also makes dealing with lost devices simpler. A lost watch containing a wallet can be quickly revoked by removing its key as a signer without needing to get a new Stellar account. And when Alice decides to purchase a new watch, it can be given a new key again without interrupting any of her existing devices. But the core reason for why SEP-30 really is valuable right now is user experience. User experience that will drive adoption. So if you'd like to learn more about SEP-30, the proposal itself is about a 15-minute read, and there's a thread on the Stellar Dev mailing list where you can ask questions, provide feedback, or make suggestions. Contributions and discussion are welcome. And now we have some time for Q&A. See what questions we have. Okay, well, thank you for listening to me talk about SEP-30.